Okay, guys, if you turn to page 20, this is page 20, we're going to go over how to identify parallel lines. Now, parallel lines have the same slope. So if we look at example 3, we see line B, line A, and line C. And it looks to me like line A and B are parallel, just looking at the picture. The only way for me to really know if they're parallel or not is to figure out what the slopes are. So what I did for you to make it easier, now you can do this two different ways. For line B, let's say, I can count my rise over my run. I can go 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5, 6. So I get a slope of 1. Or I could use these 2 points and use the slope formula. I put what the 2 points are for you to make it easy. So I'm also going to do this by doing x sub 1, y sub 1, x sub 2, y sub 2, and doing the slope formula. So I'm going to do y sub 2 minus negative 3 over 4 minus negative 2. And look, I get the same answer. So you can either do this by counting or you can do it by using the slope formula. So, okay, I put line, that was line B. I put everything in the wrong spot. So that means line B also has to be 6 over 6, which is 1. And when I do this, I do 4 minus negative 2 over 2 minus negative 4. And it just confirms what I suspected, that A and B are both parallel. So technically, I should look at line A and count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so they are parallel. Now let's look at line C. Now line C, I'm just going to use the points. So I'm going to do 2 minus negative 5 over 6 minus negative 3. And I get 7/9, which is 7/9. So lines A and B have the same slopes, so they are parallel. So again, you can either count to find the slope or use the slope formula. Now, I also want to show you that sometimes you might be asked, are these lines parallel? They're not graphed, they're just lines. So how would I determine if these 2 lines, when graphed, would be parallel? Well, I have to compare the slopes. So it's really easy for me to get the slope for this first one because it's 2/3 because it's in slope-intercept form. This one's not as easy because it's not in slope-intercept form, so I'm going to put it into slope-intercept form. So I'm going to subtract 2x from both sides. Then I'm going to divide by negative 3, divide by negative 3, divide by negative 3. And I get y equals 2/3 x minus 7/3. So m equals 2/3. So they both have the same slope. So they are parallel. Okay, so I want you to try the next group of equations on your own. Stop the video and start it again when you're done and see if you agree with me. Okay, so again, for the first one, it's easy to identify the slope. It's negative 3/4. For the next one, though, I have to put it into slope-intercept form, so I subtract 3x from both sides. Then I divide by 4, divide by 4, divide by 4, and I find y equals negative 3/4 x plus 7/4. So m equals negative 3/4, and they both have the same slope, so they are parallel. So both of those were parallel. Okay. So now I want everyone to stop the video, and you're going to do number 6 on your own. So number 6 isn't graphed, but it gives you the points. So given the points, you have to find the slope. So the slope for line A would be 5 minus 2 over 2 minus -2. So it's 3/4. The slope for line B would be 1 minus -4 over 4 minus 3. So that's 5/7. And line C is 2 minus nope, I don't put x on top, 3 minus 0 over 2 minus -2. So that's 3/4. So that means line A and line C are parallel. And we would say A is parallel to C. Okay, and that's it.